for the test pattern detection for faults. Yesterday, and I left an exercise for you to find the test pattern which would detect the stuck at fault at Z2 in your circuit, where the actual value of Z2 had to be X2, X3, but due to fault, stuck at or bridging fault, Z2F was with and X3. This was Z2F. You were required to find the test pattern which will be able to detect the OR bridging fault between X2 line. Were you able to do it? What was the final test pattern that you got when you used this expression? Anyone who did it? Please give it a try. And नहीं होल न्यूमेरिकल रहेगा पेपर, सॉल्व नहीं हो पाएंगे, and then you will face problems. CMOS कोई फायदा नहीं है.
मैम आपकी आवाज कट रही है.
Of Z2 and Z2.
Ma'am, your voice is not clear.
Take just a minute. I'm switching the net. Audible now? Abhi, is it okay? The screen and the voice?
Yes, ma'am.
Okay. So yesterday we were doing this question where Z2 was actually fault free, given as X2, X3. And if you had the bridging fault or bridging fault between X1 and X2, the expression for X2F was given like this. You were required to calculate the test vector which will test this fault at Z2. using the expression Z2 XOR Z2F should be equal to 1. If anyone had solved it, this will result into an expression x1, x2 bar, x3 equal to 1. When you solve using your digital electronics concepts, XOR solve karoge, so you will get this expression at the end, which simply means this value will be true only when x1 is 1, x2 is 0, and x3 is 1. So the test pattern which will be testing this OR bridging fault or detecting the OR bridging fault is given as 1 0 1. Right? Looking at the second example for the same, we have to find the test vector to detect stuck at 0 fault at x4. Yesterday we talked about bridging fault. Now we have to talk about stuck at fault. So stuck at 0 hai at x4. Here it is stuck at 0. So using the concept Z XOR ZF should always be true. What is the expression for Z for this circuit? Z is your output. The output would be given as, here it would be x2 plus x3, x2 plus x3 into x1. Here I have x1 bar, x4. So here I get x1 bar, x4. So what is the final value of Z? It is x1 into x2 plus x3 or x1 bar x4. Is it okay? ठीक है? Is the screen visible to you?
Yes, ma'am.
Why not me? Okay. So if this is my expression of Z, I have to implement a stuck at 0 fault at x4. Yani in this expression, I need to put x4 as 0. If I put x4 as 0 in this entire expression, my faulty expression would be x1 into x2 plus x3 because x4 is 0, x1 bar and 0 is 0. So this entire term goes to 0. So now I have Z and ZF. Using the equation 1, I can simply write this as x1 into x2 plus x3 plus x1 bar x4. This is Z. XOR it with x1 into x2 plus x3. This should always be true. I expand this for XOR. A into B bar. B bar is x1 into x2 plus x3 a whole bar plus B, that is x1 into x2 plus x3 into A bar. x1 x2 plus x3 plus x1 bar x4 इसका whole bar. Solve this. So I get this as some factor f into f bar. That would give me 0. So I'm left with this term. So I get x1 bar x4 into x1. So this again will be 0 because x1 bar into x1 will be 0. So this entire term goes to 0. So I get nothing from the first term. From the second term, what do I get? Mm, this would be x1 into x2 plus x3 whole thing multiplied by x1 x2 plus x3 ka bar into x1 bar x4. Something wrong we are doing. It is coming out to be 0 entirely.
मैम x1 बार x4 के ऊपर भी बार आएगा।
यहाँ पे हाँ, बट दिस तो मल्टीप्लाई होते ही 0 हो जाएगा ना। ये तो f इंटू एफ बार हो गया। ओके, पहला टर्म 0 नहीं होगा। दिस इज ऑल बार। The first term, this is f into f bar. This will be 0, but we will be left with this term. So that is x1 bar x4 multiplied by, take the bar of this. So that would be x1 bar plus x2 plus x3 ka bar. Expand that. Fine. This term will give you 0 because this is again f और इसको expand करेंगे तो हमें मिलेगा f bar dot x1 bar x4 का whole bar. So f and f bar, this term will be 0. So we are left with only this middle term, the multiplication of these two terms. Solve it. This will give me x1 bar x4 for the first term plus x1 bar x4. I'll solve this bar. So this gives me x2 bar into x3 bar. Now that is the final expression I have. So for this expression to be true, I only need the value or the test vector as T is set of all. X1 is 0. X2, X3 don't care because they do not have any value here. And X4 is 1. So the first test pattern is 0, XX, 1. The second test pattern according to this expression, X1 is 0, X2 is 0, X3 is also 0 since it is X3 bar and X4 is 1. So I get this. So if I expand this don't cares, the test patterns would be 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1. So this is the final test vectors which will be used to test this fault stuck at 0 at x4. Any problem? No problem. Let us repeat the problem with the path sensitization that we do. Path sensitization means वो जो values लिख के हम observe करते थे at primary output and control it using primary inputs. So for that, when I say I have to have a stuck at zero fault at x4, it means faulty input should be 0. So the actual input should have been 1, right? अगर एक faulty input is 0 to this AND gate, then G4 is definitely going to 0 due to this fault. If the faulty output G4 is 0, then the actual output G4 is 1, right? So for an AND gate without fault with one input 1 and the output as 1 requires the second input as 1 also. That is the only case. So if G2 is 1, since there is no fault here, so G2 is actually 1. So it means the value at this point should be 0. This 0 is at the fan out, so it is seen to control the primary input x1, which should be given the value of 0. The value of x1 is also seen at input of this AND gate. Since one of the input to the AND gate is 0, so I expect G3 to be 0, right? G3 0 कब होगा? एक इनपुट 0 है, so other input is don't care. यहाँ पे चाहे 0 आए तो भी G3 0 होगा. यहाँ पर अगर इस इनपुट पर 1 आए तो भी G3 0 होगा, right? So this value is don't care basically. It means my x2 and x3 also are defined as don't care. Whatever be the value here, that will be giving G1, which is a don't care, right? G3 becomes input to this G5 OR gate. एक input 0 हो गया, दूसरा faulty input is 0 and the actual input is 1. So what will be the output? The actual output will be 1 due to 0 1 at input, and the faulty output will be 0. So since the value of Z is different for fault free circuit and the faulty circuit, this fault stuck at 0 fault at x4 will be detected. What test pattern? This is actually 1. So what are the test patterns now? XX01, which I expand to 0001, 0101, 1001 and 1101. Okay? These are the 4 test patterns which can be used to detect this stuck at 0 fault at X4. This approach is called path sensitization approach, and this is the approach which uses the XOR of Z and the faulty circuit ZF. ठीक है? अभी हमारे पास टेस्ट पैटर्न्स तो आ गए हैं, but now how do we implement it? How do these testing get implemented? Testing
Ma'am,
implement करने को हम yes.
ma'am, could you explain once again explain the sensitization approach?
Okay. I need to start with the fault and then propagate that fault towards inputs and outputs. For that, here is the fault I know, and the fault that we are talking about is stuck at 0 fault at x4. इसका मतलब faulty input is 0. So faulty inputs are written in brackets. So if the faulty input is 0, तो इसका मतलब actual input 1 होना चाहिए. So the test pattern will have x4 equal to 1. The input to the AND gate G4 is 1 without fault, 0 with fault. AND gate का अगर एक भी input 0 हो जाता है, we know that the output will go to 0. So it means if the circuit is faulty for this input at this AND gate, the faulty output will be 0. Right? It is observable. The fault is observable at the output of this gate G4. If the faulty output is 0 and it is observable, then the non-faulty output or the fault-free circuit will give a value equal to 1. When will this value be 1? जब इस गेट के दोनों इनपुट्स 1 होंगे. एंड गेट है. एंड गेट का आउटपुट 1 कब होता है? जब दोनों इनपुट्स 1 होंगे. एक तो 1 है ही. This is already 1. Therefore, I want this input to be 1. Then only fault-free circuit में output will come out to be 1. If this input is 1, this is the output of a NOT gate. तो NOT gate का output 1 कब होगा? जब उसका input 0 होगा. ठीक है? अगर इस वायर पे वैल्यू 0 है, then the value of 0 will also be seen at x1. It will also be seen at the input of this AND gate. ठीक है? अगर एक इनपुट 1 हो गया इस AND गेट का, सॉरी एक इनपुट 0 हो गया इस AND गेट का, तो डेफिनेटली माय आउटपुट विल गो टू 0 irrespective of the value at the second input. यहाँ पर कोई भी वैल्यू हो, output will always be 0. So it does not matter to us what is the value at the line G1. It means x2 कोई भी वैल्यू हो सकता है, x3 भी कोई भी वैल्यू हो सकता है. 0 0 होगा तो G1 0 हो जाएगा. Else for any other combination G1 will be 1. But whatever be the value here, the output G3 will always be 0. Now the input to this OR gate is, one input is 0, the other input is 1, but due to fault it is given as 0. So what is the output G5 that I expect? Non-faulty circuit में input हो गया 0 1, so the output has to be 1. Faulty circuit में input बन गया 0 0, so the value has to be 0 for the OR gate. Since the two values are different, fault-free circuit and faulty circuit, it means the stuck at 0 fault at x4 will be detected at the output, or it is observable at the output. It gets propagated to primary output. कब propagate होगा? जब ये वाला कोई test pattern लगेगा. Test pattern क्या बना? I wrote it wrong. What is the value of x1 in my test pattern? X1 is 0. X2 is don't care. X3 is don't care. And X4 is 1. So if I expand this and take all the possible cases, this will be given as 0 0 0 1, 0 0 1 1, 0 1 0 1, and 0 1 1 1. This is same as the previous case. 0 0 0 1, or it simply 0xx1. Here also I am getting 0xx1. So you can use either approach, path sensitization approach, or the approach which uses the XOR to find the test pattern. Is it okay now?
Yes, ma'am. Thank you, ma'am.
Okay. Now, अब टेस्ट पैटर्न तो हमारे पास आ गए, लेकिन इसको यूज कैसे करेंगे? So for that we are basically going for simulation. Simulation simply means you need to write a program which will simulate your circuit and give you the value of the signal at any time. So simulation of a circuit is simply a process of computing its signals as a function of time. You have used Verilog. You can write the circuit expression in Verilog, or you can write a program in Verilog for the circuit and fault simulation. Only thing is, how do we introduce faults in that? So we'll see it today. For a simulator, fault simulator, we need to provide three things generally. The first is the circuit netlist, that is the description of the circuit, which you now know how to describe your circuit in Verilog, how to describe the connections in Verilog, right? We need to have the list of fault, assuming for the time being that we have m faults. ठीक? M fault means F1 is some other fault, F2 is other fault. For the safer side, we consider them as stuck at zero fault, but there may be some bridging fault as well. So M number of faults hai, and there are total n number of test patterns which can be given to your circuit. ठीक है, T1, T2, T3 ये सब n test vectors हैं which will be given as the input to your fault simulator. The output will simply be the result that whether the fault is detected or not. How do we know that the fault is detected? If the fault free output Z is not equal to the faulty output. If the two are different, we mean that we have detected the fault F. अगर दोनों सेम आ गए तो इसका मतलब fault detect नहीं होगा. So basically what we are doing in a fault simulator is we are reading the circuit, giving it the test vector which is used to for a fault free circuit first. कोई भी fault हम assume नहीं कर रहे हैं, neither of these fault exist, and we give the test vector and we generate the output to know what is the actual value of Z. Then we introduce one fault at a time because हमने क्या पढ़ा है, हमने पढ़ा है single stuck at fault consider करना is very safe. So एक एक stuck at fault consider करेंगे and we give the test vectors to it and see if this condition is satisfied or not. If for any test vector this condition is not satisfied, we say that the fault is detected. We have different methods of fault simulation. Okay, I missed one slide. The simplest one is serial fault simulation. As the name suggests, serial fault simulation, सीरीज में हम एक एक करके fault को analyze करेंगे. So what we basically do is, as first step, we simulate or find the output for fault free circuit. Fault free circuit को हमने सारे inputs दिए, test vectors दिए, and we find out what are the output values of Z. ठीक है, इसको हम सेव कर लेते हैं एक फाइल में. Then we simulate the same circuit for fault F1. For each test vector, we find ZF1. If ZF1 is not equal to Z, that is we compare the two values Z and ZF1. अगर ये दोनों में कहीं भी difference आता है, it means that fault F1 is detected. Then we work for the second fault and we simulate the same circuit for fault F2. Try to find out ZF2. Compare ZF2 with Z. If the two are equal, it means F2 is not detected. But in any case, if ZF2 and Z are different, then we say that the fault F2 is detected. And the process goes on until I analyze for all the faults. Right? So I need to simulate the circuit again and again for each and every fault. ठीक है, simplest approach है, एक बार ही हमें circuit define करना है, then the same circuit will be used for different test patterns and different faults. But the problem is the time is very large. हर fault के लिए I have to have different test vectors implemented. So the time complexity is quite large. Right? To solve that, to reduce that time complexity, to reduce the time required for simulation, we use the parallel fault simulation approach. Parallel fault simulation is very important because this uses the concept of parallelism. For example, we have two words. W1 is this and W2 is 1, 2, 3, 4, 5, 6. And now I need to AND logically and W1 and W2. So digital में हम क्या करते थे, इनको अगर हमें logically AND करना है, so we use bit by bit ANDing. इन दोनों को AND किया, इन दोनों को AND किया, so my result will be this. This concept of parallelism is used in parallel fault simulation. We can work with individual bits. But for that, we need to define different circuits. Here C represents a fault-free circuit. The circuit with fault F1 is represented with this CF1, then fault F2 and so on. So we have so many copies of the circuit modified for one fault at a time. For each of the circuit, we apply the test vector simultaneously so that all the circuits are running in parallel. But we need to compare the output with respect to the output of fault-free circuit. If the two are same, the fault is not detected. We say the output of the comparator is 0, that the fault F1 is not detected. But if these two values are not equal, the output of the comparator says 1, which means that the fault is detected. ठीक है? But यहाँ पर भी we have two different possibilities. Possibility one, or the first approach, is we need to simulate the faults in parallel. For example, this different faults can be simulated in parallel. And the second is approach is that instead of simulating faults in parallel, we simulate the test vectors in parallel. या तो multiple test vectors एक साथ हम use करें या multiple faults हम एक साथ use करें. But every time, say we are using W bit word, it means जो input हमारा जाएगा, that is having the fixed length of W bits. अगर W bits है, we always reserve the first bit for fault free circuit. Whatever is the output or the test pattern for fault free circuit, we put the first bit for that case. उसके बाद हम सारे faults consider करते हैं या rest of the test patterns consider करेंगे for detecting the fault. Right? तो अगर W bit word है and I am simulating the faults, at one time I am simulating W minus 1 faults simultaneously, parallelly. So this will save time as compared to my serial fault simulator, because वहां पे हर circuit को हर fault के साथ एक एक बार हमें simulate करना पड़ रहा था. But यहाँ पे multiple faults are considered at one time. Looking at approach 1, which uses multiple faults simulated together, we use the word with W bits. Total W is the width, out of which the first one is for fault free circuit and the rest are the faults which need to be considered. So in one pass of this word, I can simulate W minus 1 faults. If the number of faults in the circuit are more than W minus 1, I need to make another pass, right? वापस से मुझे एक word ये वापस देना पड़ेगा for more faults to be considered. So that is what is written over here. For Q faults where Q is greater than W minus 1, I need to use another pass or multiple pass. The number of passes would be Q upon W minus 1 taken the ceiling. Because अगर एक भी fault ज़्यादा होता है, I have to give the entire word for the input. So I will have two passes, even if the fault is just W, one more than W minus 1. Fine. So we are increasing this simulation speed as compared to a serial simulator, but both of the serial and the parallel simulator cannot be used for event driven mode. What event driven mode is? Suppose this is द सर्किट जिसका हमें फॉल्ट टेस्ट करना है. अब इस पूरे सर्किट में what we are doing, we are using the entire circuit. उसमें सारे टेस्ट पैटर्न्स हम अप्लाई करेंगे and then we are finding the output. This is what we are doing. But event driven mode simply means कि जहां पर event हो रहा है, जिस लाइन पर event हो रहा है, event means some changes are occurring due to the fault introduced. For example, here x4, then g4, then g5. Event driven simulators will only work for the lines where the event is occurring, where there are some changes, which we will see later. Deductive fault simulation, concurrent fault simulators, they can implement event driven simulation. Event driven में क्या होता है, पूरा सर्किट का डिस्क्रिप्शन नहीं चाहिए होता है, so the working becomes easy, the time is less required, because now we have to analyze only 3 lines for the entire circuit to detect the effect of the fault. So serial and parallel fault simulators, they cannot work for event driven mode. उन्हें तो पूरा सर्किट ही रन कराना होता है. ठीक है. For example, this is a given circuit. एक AND gate है, एक NOT gate है, एक OR gate है. Fine. 3-bit word है. So the length of the word is 3, out of which the first bit, it is bit 0, which is representing the fault free circuit. The second bit represents one of the fault. यहाँ पे मेरे सर्किट में कितने fault sites हैं total? 1, 2, 3, 4, 5, 6, 7. So total I have 7 faulty sites, and maximally I can have 14 stuck at faults. हर साइड पर 2. So 14 stuck at fault में से right now I am considering only 2 faults, that is C stuck at 0, F stuck at 1. 2 faults are considered simultaneously. So parallelly we are working with 2 faults. So this bit represents or is used for a circuit with the fault C stuck at 0. The second bit, bit 2, is used for the circuit which has the fault F stuck at 1. Fine. Input हमने दिया 1 1 1 at A and B. We need to check what happens at output if the faults are detected or not. So pass this 1 1 1 to the input of this AND gate as it is. This is a fan out. So the input at B is 1 1 1, but C gets an error stuck at 0. Right? So what will be the value that is read at the input of this AND gate? ये पहला one as it is, because this is for the fault free circuit. The second bit is representing C stuck at 0. So the value should go to 0, because this is the bit which considers this fault. So the value here goes to 0. But the second bit, bit 2, this represents the circuit stuck at 1. So here there is no effect for stuck at 1. I am considering single fault. So the value remains 1. So now the input to the AND gate becomes 1 1 1 on one wire and 1 0 1 on the other. If I logically AND the two inputs, I will get the value on wire E as 1 0 1. I am simply ANDing 1 1 1 with 1 0 1. So the output of E is 1 0 1. Okay? Similarly, this input at B is seen at D because यहाँ पर कोई fault नहीं है. So the input to this NOT gate becomes 1 1 1. NOT gate का output क्या होगा? 0 0 0. But now I have to implement a fault which says F stuck at 1. Right? F stuck at 1. It simply means that bit 2 will go to 1. This is the fault free circuit. So the value remains as it is. This is for C stuck at 0. The value remains as it is because here we are considering F stuck at 1. So this value bit 2 is getting stuck at 1, right, due to this fault. Now the input to this OR gate is 101 and 001. So what will be my logical output? 101 OR with 001. What will the result be? 101, this one. Now compare the outputs. This is the output for fault-free circuit. This is the output when the stuck at fault was C stuck at 0. This was for C stuck at 0. The two values are different. Fault free is 1, but is error ke liye, is fault ke liye, the output goes to 0. It means this fault is detected using the test pattern 1 1. This is what my test pattern is. So I am able to detect this stuck at fault C stuck at 0. But if I look at F stuck at 1 case, the output when F is stuck at 1 is 1, which is same as fault free circuit. It means this fault F stuck at 1 is not detected. Right? It is only C stuck at 0 which is detected. Though I have simultaneously implemented or simulated for two faults, but out of which only one of the fault is detected. Okay? Is this clear? How simulator works? We are basically giving different inputs and for different faults consideration, and which fault is detected, that will be dependent on the output. If the output is same as fault free circuit, the fault is not detected, but if it is different, it will be detected. Fine. We'll stop here and we'll continue with this fault simulation and see how the faults are actually implemented in software. अभी ये तो समझ लिया हमने सिमुलेटर कैसे काम करता है, but how does it know that the stuck at 0 or stuck at 1 fault has to be considered? That we'll do in the next class. This is we are doing chapter number 5 from Bushnell. So that is all for today. Any problem?
मैम यहाँ पे 640 साइट्स नहीं होंगी?
6 क्यों? ये फैन आउट है ना, तो 3 तो यही हो गई. 4th ये A वाला वायर, 5th is E, 6th is F and 7th is G.
ओके
ठीक है.
मैम.
फैन आउट में ये तीनों अलग अलग साइड्स होंगी. A अलग होगा, C अलग होगा, D अलग होगा.
ओके मैम.
ये तो फॉल्ट फ्री है ना मैम?
कौन सा?
ए
A. हाँ, A फॉल्ट फ्री है. सिर्फ दो फॉल्ट्स कंसिडर करी हैं अभी हमने, स्टक एट 0 और एट C एंड स्टक एट 1 एट F. ठीक है. अगर 14 फॉल्ट पूरी एक साथ हमें करनी है तो हमें वर्ड लेंथ जो है, बिट लेंथ, सॉरी वर्ड का लेंथ, वो 15 बिट लेना पड़ेगा. 14 तो फॉल्ट और एक फॉल्ट फ्री सर्किट. ठीक है. वील सी इट इन द नेक्स्ट क्लास. हाउ डू वी डिटरमिन कि ये वैल्यू क्या होना चाहिए फॉर दीज फॉल्ट्स. वील सी इट इन द नेक्स्ट क्लास when we work with the insertion of the faults. Fine. So we'll continue in the next class and I'm ending the class for today.
Thank you, ma'am.
Okay. You may leave, please.